Today we are going to focus on, we're still going to be solving for quadratic equations. However, we are going to notice that they're going to be provided in a different format. So we started off with equations when they were already factored, and this was very beneficial to us because we had two numbers that were multiplying that equaled 0. So when we have two numbers that multiply that equal 0, we know that either this is equal to 0 or this quantity is equal to 0. But one of them definitely is equal to 0. Then the next step was we were provided this, and what we did was we factored this, and we went through a litany of factoring testing to see which one applied, which technique we can use to factor this. And if we factor this, it actually equals this. So we like it when it's equal to 0, because when it's equal to 0, we can set it equal to 0 as a product of two numbers, and we know that one of those two numbers must equal 0. When we look at this equation is a little bit different and not as beneficial. And reason being is because if we turned it into the product of two numbers that equal 10, that doesn't really tell us anything. We have no idea what this could be. We have no idea what that can be. These numbers, there are an infinite number of numbers that can be solutions in here into these two numbers. It can be 3 and 10, it can be -3 and -10, it can be 1 and 10, not -3 and 10, sorry, it can be 1 and 10, -2 and 5, -2 and -5, it could be 1/2 and 20, so there are an infinite number of solutions. In this top one, because it equals 0, there's only a limited number of numbers that can go into there. So that's why it is important that when we set up these equations that they are equal to 0. So after we factor and we have two numbers multiplying, that we know that one of them must equal 0. So we get this starting problem, and we see immediately, we should notice that this is not equal to 0. So we're going to have a new step 1. Our new step 1 is going to be set equal to 0. So we have to make that right side of the equation, or left side, right side, equal to 0. So we got to get rid of this 6 on the right side. What's going to get rid of a positive 6 is a -6. And I'm going to put it underneath its like term. That's a constant, so I'll put it underneath the constant. And then we'll simplify that left side. You get x squared minus 6x minus 16 equals 0. So now we've set it equal to 0, which is really beneficial. And now we're going to look and see, can we factor that? So we're going to go through that same list again that we used to do. Does it have a greatest common factor? No. No number and no variable is shared amongst the three of those. The next one, is it difference of squares? No, it doesn't have two terms. Number 4 is binomial square. This is not a binomial square because my second sign is negative, and it must be. So can I use a times c? Yes, it has 3 terms, so a times c, we use 3 terms. A is the coefficient of x squared, which is 1. C is -16. 1 times -16 is -16. My factors of 16 are 1 and 16, 2 and 8, 4 and 4. My signs are different. When that's a negative, second sign is negative, it means they're different. And then I look over here and I see that the bigger gets the negative. So the bigger of these two factor pairs is going to get the negative. And since my signs are different, that means the other one has to be positive. That leaves me with -15, -6, and 0. My middle is -6, so I'm going to use those factor pairs. And I'm going to rewrite this equation. X squared, instead of writing -6x, I'm going to write positive 2x minus 8x minus 16 equals 0. I'm going to group the first two and the second two. From the first two, I can factor out an x. I get x plus 2. From the second set of numbers, I'm going to factor out a negative 8. I notice that my first term is negative, so I have to factor out a negative, and that gives me x plus 2 equals 0. The two items in the parentheses are the same, so I'm going to pull that out, and that leaves me with x minus 8. Now, much like we did in day 2, we know that the product of two numbers equals 0, so one of those, either this has to equal 0 or this has to equal 0. And we're going to isolate the variable. We get x equals negative 2. We're going to isolate the variable. We get x equals 8. So my solutions to that equation are negative 2 and negative 8. Those are the two values. When plugged into this equation, makes the left side equal the right side. So if I plug in negative 2 squared minus 6 times negative 2 minus 10 should equal 6. Negative 2 squared is 4. Negative 6 times negative 2 is positive 12. Minus 10, that's 16 minus 10 is 6. 6 equals 6, so that is a solution. Notice in this one that we've got more than just one thing on each side. So it's all over the place. This equation is on both sides, and so we have to decide where we're going to push everything. Are we going to move everything to the left, or are we going to move everything to the right? So when we say set equal to 0, we also have to remember this little caveat. K squared must be positive. That's not how you spell positive. Positive. Okay? So my k squared, whatever my squared value, must be positive. So if I moved it over here to get 0 on the left side, you'd have a negative k squared, and we don't want that. We don't want k squared to be negative. So we're actually going to have to move these two items over to that side. So I'm going to subtract 7. K squared minus 7 equals negative 6k. Remember, these are not like terms, so negative 7 and k squared can't combine. Now I'm going to move this negative 6k, and I'm going to add 6k to both sides. So I get k squared plus 6k minus 7 equals 0. That 6k is not a like term with k squared or the constant, hence why I have it. And notice that I write my statement, my trinomial, 3 terms in standard form. It's k squared, k to the first, and then my constant, which doesn't have any k. So when we write that, we always want to write it in standard form. All right, now we're done. We've set it equal to 0. So now, is it the difference of squares? No. Is it a binomial square? No. Is it a times c? Yeah, let's try it. A is 1, c is negative 7. Factors of 7 are 1 and 7. Signs are different. When that's negative, they're different. And the bigger is positive. So that gives me 6. That's equal to my middle term, which is good. Just erasing this. So that becomes k squared minus k plus 7k minus 7. And I got that from there. I changed the positive 6k into this because that simplifies to those two same things. Equals 0. Now we're going to group. We're going to pull out a k, and you get k minus 1. We're going to pull out a 7. You get k minus 1 equals 0. They both have a k minus 1, so we'll pull that out. And when you pull it out, you're left with k plus 7. Now we're going to set each one equal to 0. And k plus 7 equals 0. We're going to add 1. We get k equals 1. We're going to subtract 7. You get k equals negative 7. -7, 1 are my solutions. Remember, put them in numerical order. All right, I want you to try this one. So pause the video, take a second, work on that, show each of the steps, make sure that you're showing your work, make sure you follow. Hopefully you have a note card that you're referring to. So pause it, and when you're ready, you can push play and I'll go through the answer. Okay, so this is not set equal to 0. So we're going to add 2 to both sides, and you get 2k squared plus 2x squared plus 5x plus 2 equals 0. So I set it equal to 0. Does it have a GCF? No. It does go into these two, but 2 doesn't go into this. So that these two have x's, but this doesn't. So it has no GCF. Difference of squares? No. Binomial square? No. A times C. Did I forget GFC on that last one? I did forget GFC. Mr. Mac. That one right here. Sorry. GFC. I knew it. I knew it. My brain told me. All right. A is 2. C is 2. That makes 4. Factors of 4 are 1 and 4. 2 and 2. Signs are the same. Both are positive. 5, 4. 5 is my middle. So 2x squared plus x plus 4x plus 2 equals 0. We're going to group. We'll factor out an x. You get 2x plus 1. We'll group. We'll factor out a 2. You get 2x plus 1. They both have 2x plus 1. And that leaves you with x plus 2. Set them equal to 0. 2x plus 1 equals 0. X plus 2 equals 0. We're going to isolate the variable x. There's 2 things happening to it. Something's being added and something's being multiplied. We always get rid of things being added and subtracted. Divide by 2 now, and you get x equals -1/2. Subtract 2, you get x minus 2. So my solution set is -2 minus 1/2. Whoa, look at that one. That's pretty overwhelming. So remember, I'm first focusing on my k-squares. So I want my k-squares to be on the same side, first of all. I'm moving everything to one side. I'm going to combine the k-squares. I'm going to combine the k's and the constants. So which way am I going to move it? If I subtract 3, if I get rid of everything on the left side, that would give me a -4k squared. And we don't want a negative. So I'm going to get rid of this k squared on this side, and I'm going to move it over to this one. That gives me 4k squared, not 4k to the 4th. We're not multiplying. We're adding like terms. We combine their coefficients. 3 and 1 makes 4. And then I rewrite it. These canceled. So you're left with 3k minus 2. Now I'm going to move the k's. So I'm going to subtract a 3k. I'm going to line it up with its like term. 4k squared minus 10k plus 2 equals -2. So I'm almost there. It's almost equal to 0. So I'm going to get rid of the -2 by adding 2. 4k squared minus 10k plus 4 equals 0. So we did step 1. It is now set equal to 0. Next thing is greatest common factor. Does it have a greatest common factor? Yes. In fact, it does. There is a 2 that goes into each of these 3 terms. So if I factor out a 2, I get 2k squared minus 5k plus 2 equals 0. Okay, that's cool. Now, I want to see, can I still factor that portion? So I'm going to go through my list. I already did GCF. Is it the difference of squares? No. Is it a binomial square? No. Is it, can I do A times C? Yes. I'm going to do 2 times 2, which equals 4. 1 and 4, 2 and 2. Signs are the same, both are negative. So that's -5, that's -4. That's equal to my middle. So I have 2 times the quantity, 2k squared minus k minus 4k plus 2 equals 0. I'm going to group. So I can take out a k from there. That gives me 2k minus 1. I'm going to take out a negative, hello, I said negative and literally wrote positive, -2, which gives me 2k minus 1. And now we're going to pull that 2k minus 1. So we have the 2 on the outside. We have the 2k minus 1 that they have in common, and that leaves me with k minus 2. So this is that example where you have 3 numbers multiplying to make 0. One of them still has to be 0. There's no other way of getting 0 when you multiply other than one of those 3 numbers equaling 0. Well, we set it equal to 0. Well, 2 can't be 0 because 2 is a constant, and there's no variable there for us to figure out. So that just goes away and negates itself. But now we set the other 2 quantities equal to 0. We add 1, divide by 2, we get k equals 1/2. We add 2, and we get our solution is 1/2, comma, 2. All right, so that is the culminating, that is the final one. That is the most crazy quadratic equation that you're going to get. All right, so hopefully that makes sense to you. Come and see me if you need some help.